In this video, I just wanted to run through the solutions of 5.5 and 5.6 on page 70 of your textbook. So the first question asks you to define three types of bonds. Ionic bond, now that's a junior cert definition. So ionic bond is the force of attraction between oppositely charged ions in a compound, okay? The second one then is polar covalent bond. So this is a bond in which there is unequal sharing of the electron pair, okay? And then you could say this causes one end of the molecule to be slightly positive and one end to be slightly negative. And remember, in a covalent bond, okay, there's a slightly negative and a slightly positive region because of the unequal sharing of the electrons. The electrons are closer to the atom there. That is more electronegative. So unequal sharing of the electron pair, resulting in one end of the molecule to be slightly positive and the other end of the molecule to be slightly negative, okay? The last definition you were asked to describe then was hydrogen bonding. And hydrogen bonding, there are special types of dipole-dipole attractions or interactions between. Hydrogen bonds are intermolecular forces. So they are between molecules, and between molecules where you have hydrogen bonded to either fluorine, oxygen, or nitrogen, okay? The top two are intramolecular bonds. They hold atoms together within molecules, but hydrogen bonding are types of intermolecular. Remember, in between one molecule and the next molecule, okay? The next part of 5.5 then asks you to explain why the boiling point of sodium chloride, okay, is so much, that Kelvin is so much higher than the other two. Well, all you have to say there is that hydrogen bonding has ionic forces or ionic bonds between, okay, so you have Na plus, Cl minus, and they are very, very, very strong. The stronger the bond, the more energy required to separate the ions from each other, and therefore ionic compounds would have very, very high boiling points because the ions will attract very closely or very strongly to each other. Therefore, you need a lot of energy, high boiling point, to separate those ions. Now, 5.6 asks you specifically to choose elements within the first 36. Okay, you're going to be asked about the first 36. So you need your periodic table to answer this question. So they asked you to name one non-metal which exists as single atoms. Now, you should know from junior cert to separate the periodic table into metals and non-metals. You start with boron and aluminium, and you put a line there, and then you go in between like that. Okay, so you have silicon here, and you have arsenic there. So the non-metals are all up here in the top right-hand corner. So you look for something there now that exists as single atoms. So you could say boron, carbon, phosphorus, sulfur, selenium, arsenic. They're all single. Okay, they're not looking for diatomic elements. So don't mention oxygen, nitrogen, chlorine, those kind of ones. Okay, part 2 then of that asks you to give the formula of an ionic compound formed from element in group 2. So you need to look for group 2. So when I looked at group 2 there, you see things like magnesium. So ionic compounds, so magnesium and maybe chlorine. Okay, now remember that magnesium's in group 2, so that's going to form a +2 charge. Chlorine's in group 7, so -1, because remember chlorine has 7 electrons of its own. It needs to get 1. So watch now that the charge is balanced. So you're going to need 2 chlorines, aren't you? So that your +2 -2 charge balances out. You could use calcium chloride if you wanted to as well. They'd all be ionic in nature. Okay, part 3 of that then asks you to give the formula of covalent compound formed from an element in group 5. So if you look again at 5, first thing I see there is nitrogen. Now nitrogen has 1, 2, 3, 4, 5 electrons of its own because it's in group 5. So it would need 3 atoms of hydrogen then to satisfy octet's rule. So you'd write down NH3, and remember that you dot one atom's electrons and cross the other atom's electrons. You could also same sort of thing for phosphorus, okay? So that's phosphine, or if you wanted to, you could do a chloride. So you'd have 1, 2, 3, 4, 5, 6, and here you'd have chlorine 1, 2, 3, 4, 5, 6, all covalent. Okay, all covalent molecules there. What do you understand by electronegativity? Well, that's your definition. It's the relative force of attraction that an atom and a molecule has for what? For a shared pair of electrons in a covalent bond. That definition comes up an awful lot. in the exam papers. Now, comment on the nature of bonds that you would expect to find in MgS and phosphine. Now, nature of bonding, lads, you need to look up your table of electronegativity values. When you do, magnesium has a value of 1.31 and sulfur has a value of 2.58. When you subtract those values, look, you get 1.27. So what category does that fall into? Well, it's greater than 0.4, but it is less than 1.7. So I'm going to say that it's polar covalent bonding or polar covalent bonds, okay? Phosphine then, on the other hand, when you look up P, it's 2.19 and hydrogen is 2.2. So the difference there is 0.1. So that's going to be pure covalent, isn't it? The electrons are shared equally there in the bonds, all right? The last part then, it said which of the first 36 elements would form a compound or the compound that you would expect to have the greatest ionic character. Now, you want to find the greatest difference in electronegativity, okay? So if I was you, I would look at your electronegativity table, looking at the first 36 elements now, remember, and I would look for the element which is the most electronegative first. When you do, you'll see it's fluorine. Fluorine is a value of 3.98. There isn't an element in the first 36 that has a greater value for electronegativity than that. So fluorine is going to take the electrons. Now, what has the least electronegativity value or the lowest electronegativity value in the first 36? And it's K, 0.82. So when you combine those, you're going to get a compound called KF. So that's the compound that would have the greatest ionic character, because when you subtract them, you're getting an electronegativity difference. When you take 0.82 from 3.98, you're getting a difference there, look, of 3.16, and that is the greatest difference that you can have in the first 36. Is that okay? Thank you.